While doing research for another video, I came across this clip from a TV show called Freaky Links.
Alright, it's coming through.
Derek, this is impossible.
That's what they said about the coelacanth.
What's that?
It's this fish that everybody thought was extinct, but it isn't.
This statement isn't uncommon in cryptozoological discussions. Many hold up the existence of the coelacanth, a fish that was believed to have been extinct for 66 million years before it was rediscovered in a fisherman's catch in 1938, as evidence that prehistoric animals could still be out there. After all, if the coelacanth survived so long undetected, maybe the mokele-mbembe is really a dinosaur, perhaps the Loch Ness Monster is a plesiosaur, and maybe pterodactyls still roam the Wild West. While I have no doubt that there are plenty of undiscovered animals still out there, this is the wrong conclusion to draw from the coelacanth's discovery. When comparing different cryptids to the coelacanth, it's important to compare the reasons why the coelacanth evaded scientific discovery for so many years, to potential reasons why other cryptids have evaded discovery. If you want to evaluate how likely a cryptid is to exist, an important question is why has the animal gone undiscovered for so long? The coelacanth was discovered in the waters of South Africa, an area that isn't exactly remote, but at the same time hadn't been widely explored by Western scientists in 1938. In fact, saying the coelacanth wasn't rediscovered until 1938 is inaccurate. It had already been known for years by the locals. Fishermen in the Comoro Islands referred to it as the kambesa. They would dry and eat the fish, and use its scales in things like bike tires. While in the 1930s it was possible that local groups knew of an unknown fish and the worldwide scientific community didn't, with greater international communication this is more unlikely. The coelacanth is the best known example of the Lazarus taxon. The Lazarus taxon is any animal which seems to disappear from the fossil record for an extended period of time, only to reappear later. For example, in 1846 paleontologist and biologist Richard Owens described a new species of whale, Pseudo-Orca crassidens, based on a 126,000-year-old skull that was found 3 years prior. For well over a decade it was thought that the species was extinct, until in 1861 when carcasses washed ashore in Denmark. Today, Pseudo-Orca crassidens is more commonly known as the false killer whale. So why can't cryptids like surviving plesiosaurs and pterosaurs be modern examples of Lazarus taxa? What makes them different? One major distinction is that the fossil record doesn't treat all animals equally. During the process of fossilization, larger, harder, more durable body parts, such as bones or exoskeletons, are preserved more often. Soft-bodied, cartilaginous, or very small body parts are preserved less often. For example, since an octopus is mostly muscles and skin and has no bones, fossils of prehistoric octopi are rare. It's also why the coelacanth had such a large gap in the fossil record. The bones of coelacanths are small and fragile, and thus have a low potential for preservation. Another point is that the further from the present day an animal lived, the more time it would need to hide from the fossil record, and thus the lower its chances of doing so would be. The false killer whale had larger and thicker bones than the coelacanth, making it more likely to fossilize. However, at the time of its discovery, there was only about a 130,000-year gap in the fossil record for the animal. In such a short span of time, not many fossils were formed. Larger prehistoric animals like plesiosaurs, if they survived into the modern day, would have millions of years of fossils dating between 66 million years ago, when they were said to have gone extinct, and today. Since there are no fossils younger than 66 million years ago, that means they went extinct during that time. This leads to the third point. The fossil record has been greatly expanded since 1938. Coelacanth fossils have been found from the Paleocene and Miocene, bringing the gap down from 66 million years to just 20 million years. This is still a lot, but as mentioned, the coelacanth doesn't fossilize well. If extinct animals like the plesiosaur or brontosaurus, with their large calcified bones, were to survive until today, we would have certainly found their fossils by now. In fact, we would have probably patched up their gap in the fossil record before we patched up the coelacanths. The probability that they wouldn't have been found in any well-researched fossil formations by now is hard to calculate, but it's extremely close to 0%. And it's not just non-avian dinosaurs that suffer from this problem. In the 1960s, cryptozoologist Bernard Heuvelmans identified multiple types of cryptids. Three of these cryptids, the super otter, the many-humped sea serpent, and the many-finned sea serpent, he theorized were late surviving members of the Archaeoceti, a group of primitive whales that went extinct 23 million years ago. Now 23 million years isn't as long as 66 million, which theoretically means that there'd be a higher chance of them hiding from the fossil record and still being around today. However, whales tend to have very large bones, and Archaeoceti such as Basilosaurus were no exception to this. Even some animals that went extinct somewhat recently should still have recent fossils if they still exist. Another marine animal thought by some to have made it into the present day is the megalodon, a large shark. Megalodon had a cartilaginous skeleton which doesn't fossilize well, and it only went extinct around 3 million years ago. This shark had a mouthful of very large teeth, which unlike the body are preserved very well in the fossil record, and it shed these on a regular basis. If this 50-ton shark made it into modern times, we should expect to see an abundance of teeth in the more recent fossil records, but there aren't any. This lack of abundant newer megalodon teeth is one of the best arguments in favor of the megalodon being extinct. A 2014 research study used the known ages of megalodon teeth to estimate when the shark went extinct, and found the probability of its survival in the present day to be just 0.06%. Another point is that larger, non-avian dinosaurs would have had to survive the KPJ extinction event, which is the mass extinction of dinosaur species theorized to have been caused by a large asteroid impact. While some animals did survive this extinction, these usually aren't the animals cryptozoologists are talking about. Look at the mokele-mbembe for example. Some have theorized that the mokele-mbembe was a late surviving sauropod, arguably the group of animals with the least hope of surviving the extinction. Sauropods were large vegetarian animals that needed a lot of food, so even if they did survive the initial impact, they would still need to eat hundreds of kilograms of plants each day to avoid starving. Since the impact caused a winter that killed most of the plant life on Earth, there's simply no way the species could have survived. You also have to consider the butterfly effect these animals surviving would have. Today's modern wildlife was only made possible in the first place by the extinction of prior animals. Let's use the late surviving plesiosaur as an example. If a species of plesiosaur were to survive the KPJ mass extinction, it would be left with a total monopoly over the marine ecosystem. Due to competition, if plesiosaurs did survive, marine mammals such as whales probably wouldn't have had the chance to become dominant animals in the ecosystem. So while we know that the existence of the coelacanth doesn't mean that any prehistoric animal could still be out there, which potential Lazarus taxa are still within the realm of possibility? The most likely are animals that went extinct so recently that there haven't been many opportunities for new fossils to appear. The thylacine, which was officially declared extinct in the 1980s, is the perfect example of this. Even a giant ground sloth, which is theorized to be the animal behind reports of the mapinguari in Brazil, could have survived without leaving many fossil remains. It went extinct around 8000 BC, which isn't that long in terms of a fossil gap. But then, what about cryptids that have been described as looking like late surviving dinosaurs, plesiosaurs, and other prehistoric creatures? Does this mean they can't exist? While it doesn't seem possible, that's not necessarily true. It just means that if they do exist, then they aren't actually late surviving dinosaurs, plesiosaurs, and so on. It could be a case of convergent evolution, which is when different animals will independently evolve the same traits. Sometimes this is an internal adaptation, such as how some amphibians, fish, reptiles, and a bunch of other animals all developed the ability to produce venom. But sometimes this affects the entire appearance of an animal. Sharks, dolphins, and the extinct ichthyosaurs all ended up with a similar appearance for optimized swimming, despite one being a cartilaginous fish, one being a mammal, and one being a reptile. This last example is especially important as it demonstrates that a modern animal can evolve to have the appearance of an unrelated and extinct species. The amphibians Prianosuchus and Brachiosaurus both lived in the Permian era, going extinct millions of years before even the dinosaurs appeared. However, they still bear a striking similarity to the modern-day gharial and the axolotl. The Triassic reptile Henotus looks similar to a modern turtle, but it was actually more closely related to a plesiosaur. If no one knew what a dolphin was, and you were the first person to see one, some people may theorize that what you saw was a late surviving ichthyosaur. Other people may say that you just misidentified a shark. So if convergent evolution is behind some sightings of prehistoric animals, which ones could it potentially explain? The mokele-mbembe is often thought to be a sauropod that survived extinction. Some cryptozoologists, however, have theorized that it could be a mammal which independently developed a similar appearance. Others thought that an undiscovered species of giant reptile is behind the sightings. When it comes to plesiosaur sightings, cryptozoologist Bernard Heuvelmans came up with an interesting explanation. He thought that these were actually sightings of a cryptid called the long-necked seal. Basically, the long neck is a type of seal which has adopted a body shape similar to a plesiosaur's, having both flippers and a distinctive long neck. The discovery of living coelacanths was incredibly cool, but it shouldn't be used as an example for why every prehistoric animal could still be out there. Bone structure or lack of bones, behavior, location, and extinction date should all be considered when you evaluate an extinct animal's chances of surviving. The rediscovery of the coelacanth was significant because of how rare it was. While it would be cool if there were plesiosaurs, pterosaurs, and other prehistoric survivors still out there, if you look at the facts you can see that they aren't. But there are still a lot of other animals waiting to be discovered. I'd like to thank Chris, who helped out a lot with the script and visuals of this video. I'd also like to thank Enigma, Robin, Jimmy Esoteric, Equarep, Tyler Greenfield, Cameron McCormick, Mick Toasty, and Michaela. If you have any comments or questions, please leave them below. If you'd like to help me out, consider sharing this video with someone you think may like it. I'll leave a link to my Patreon and other social media accounts in the description. I'll also post a playlist of other cryptozoology videos. If I sound a little weird in this video, I apologize. I've been dealing with an illness recently. That's all for this video. I will see you in the next one.